This is a challenge problem on verifying trig identities. I kind of hesitate a little bit to call it a challenge problem. It is a tough problem, but I don't think it's out of the realm of possibility of what you can do if you understand verifying trig identities. But I still want a harder example to go over just so we can see what's going on. Um, I kind of want to try and show you that you can kind of recognize certain patterns and just kind of try things and sometimes see where you're supposed to go in one of these problems. So anyway, I am going to I'll do one side in a different color than the other side so we can kind of see what's going on. Um, but let me put an equal sign here. Okay. So first thing I will put is we're going to take care of this left side. And by the way, because every function we're dealing with has a parenthesis x, there's nothing inside the trig functions. I'm just going to drop the parenthesis x so I'm not writing parenthesis x for every single identity that I have to, or every single function I have to write. But anyway, so first sort of hint, when you see, you know, 1 plus sign or something like that in the denominator of a fraction, that's a really good sign that I can use a Pythagorean conjugate to simplify this fraction or just kind of make it look nicer. Um, and so I'm going to multiply this fraction by something that equals 1. So I don't need to do this to both sides. This equals 1, so I'm just keeping the fraction the same. I'm multiplying it by 1. And I multiply it by the conjugate, so I have 1 plus sign on the bottom, so I multiply that by 1 minus sign. And it does have to be equal to 1, so I keep 1 minus sign on the top. Now, um, I've referenced in the worksheet, so I'm not just, you can assume I don't have this memorized, but for the test, like I have this memorized, I'm not figuring out the conjugate. But if I have 1 minus sign times 1 plus sign, that equals cosine squared. And so if I kind of continue my calculation, we have a fraction bar here, and we get cosine squared. And then on the top, I get 1 minus sine times 1 minus sine. Okay. Let's briefly actually leave this alone and let's move to the other side of the equation. This is one of those examples where working from both sides can really help you, at least in my opinion. So we have secant minus tangent squared. And we are simply going to start by squaring that quantity, right? So remember, you have to FOIL. We can't just bring the squared inside the parentheses. So I get secant squared minus 2 secant times tangent plus tangent squared. Okay, now let's convert all of these secants and tangents into their respective functions that involve sine and cosine. So secant, if you aren't aware at this point in the worksheet, hopefully you are, is 1 over cosine, and tangent is sine over cosine. So here I'm going to get 1 over cosine squared minus 2, and then secant is 1 over cosine, tangent is sine over cosine, and tangent squared is sine squared over cosine squared. And what you might notice, if I go down one more line, is that if I combine the fractions in the middle, I'm going to get sine over cosine squared plus sine squared over cosine squared. Every single one of these fractions is over top of a cosine squared. And so what we can do, if we bring down this quantity, well, we have a cosine squared in this denominator, and so we can actually multiply everything in this equation by a cosine squared. So I like to kind of represent that. I'll put brackets around the whole equation, and this is all getting multiplied by a cosine squared. And that cosine is going to cancel with every single one of these cosines. And again, I'll erase those arrows, but all of those cosines cancel, and we get this new equation where we have 1 minus sine, 1 minus sine, and then we have 1 minus 2 sine plus sine squared. And it might be becoming clear what's actually going to happen here. If I now FOIL out the left side of my equation, I will get 1 squared, excuse me, which is just 1, minus 2 sine plus sine squared. And we have now balanced our equation. Our equation is the exact same on both sides. If you really wanted to take this further, right, you could cancel those sine squareds, cancel those 2 sines, and you'll get 1 equals 1. But in the end, I have the same equation on both sides, and so no matter what I... Sorry, I've been recording videos all day, my throat is dry. But again, no matter what value of theta I plug in, I will get the same thing on both sides. These equations are equivalent, and so this is indeed an identity, and we have verified it. So again, moral of the story, sometimes it looks really complicated, but if you just try different things and see what works, pick up on patterns, again, that Pythagorean conjugate under the denominator, good sign to use that technique. I FOILed just to see what happened. You know, one side's all sines and cosines, so if I can make the other sides all sines and cosines, you know, maybe I'll find some similarities. But again, try different things, get used to it. But that is a slightly more involved example for verifying a trig identity.